Everything good? My friends, what is the autonomic nervous system? What is that? If something is autonomic, what does that mean? It's automatic. It runs itself. You have no voluntary control over it. Got it? Okay. Your autonomic nervous system is part of your motor system. But it's not the little red man who says, move your arm, move your leg. Are you with me? This is coming from the medulla, and it's automatic. It runs itself. Alrighty? It talks to your smooth muscles, to your cardiac muscles, and to glands like your salivary glands. Make sense? Okay. Subconscious. Other names, the involuntary nervous system, the visceral motor system. Yeah, that's what smooth muscles are around your organs, your viscera. And as you can see, brain and spinal cord, body, sensory and motor. Your motor has to the body and to the organs. And this is what today's chapter is. The one going to the organs is your sympathetic and your parasympathetic. Which one is fight or flight?
Sympathetic.
And therefore rest and digest is parasympathetic. Now please, please, please don't overthink this. If somebody says, I'm sympathetic to your problem, do they have your problem? No, you have the problem, but they feel for you. Got it? In human terms, that's empathy. Got it? Well, we also call it sympathy. Are you with me? Well, that's what they're saying here, is that you don't have control over your sympathetic nervous system. It runs it on its own. Got it? Now, what is the prefix para? All right, math whizzes. What do I call these two lines? Because?
Side by side.
Thank you. Your parasympathetic nervous system lies right beside your sympathetic nervous system. Because your parasympathetic and sympathetic both go to the same organs. One says speed up your heart, one says slow down your heart. One says speed up your digestion, one says slows down your digestion. Are you with me? That's why they're parallel. They're next to each other. All right. So, we need to make sure that we understand that there are differences between the sympathetic, the parasympathetic, and our regular nervous system, the one going to your arms and legs, which we're going to call the somatic nervous system, right? Soma to your arms and legs, to your body. Here's the thing. How many nerves from your spinal cord out to your fingers to move your fingers? One. From your fingers back to your spinal cord? One. Got it? But your sympathetic and parasympathetic have two, from your medulla to your organ, or from your organ back to your medulla, where they come from. So the first one is going to be called the preganglionic, and the second one is the postganglionic. What's a ganglion? The body where the first one is talking to. That's a ganglion. Are you with me? So if we had this motor neuron here, and then we had a second motor neuron here. This is the pre, this is the post, and right here is the ganglion. Because that's where the body is of the second guy. Are you with me? All right. As opposed to in the somatic, We only have one axon. 10-4? All right. 1 versus 2. That's why in this one, we don't say pre and post. Because there's only one of them. All right. Put a giant star by this picture. If you are a read-write, say this stuff out loud to yourself. If you are, if you are or write it over and over. If you are kinesthetic, draw this. If you're visual, draw this. Okay? Don't make it difficult. Just do what you have to do. If you can do it 3 times, you've learned it. Okay? If you're doing it 12 times and you haven't learned it, that's not the way to do it for you. Got it? You'll know after 3 times of whatever it is you're going to do whether it works or not. But don't wait until the Sunday before the Sunday night test to figure out which one is the way you need. Okay? Somatic. 1 neuron. Sympathetic, we're going to make it green. Parasympathetic, purple. 1, 2. 1, 2. Parasympathetic. 1, 2. Are you with me? Okay. So that's test question number 1. Which system uses 2 neurons? Which system uses 1 neuron? Everybody with me? Good. Second question. Who are they talking to? Who's the effector? Remember, this is all motor. So who are we going to make move? Somatic? It's always skeletal muscle. That's the chapter we had, in the last test, right? And if we're going to use skeletal muscle, who is the neurotransmitter of choice?
Acetylcholine.
Acetylcholine, all the time. So you see, this you shouldn't even have to study. Okay? And when acetylcholine tells my muscle to do something, is my muscle going to do it or not do it? Going to do it. It's stimulatory all the time. My acetylcholine says, do this, I'm going to do this. Are you with me? Okay. And it's voluntary because I decided to do this. Yeah? Okay. Well, let's do sympathetic first. Sympathetic, we all agree, is fight or flight, right? 1, 2. Okay? But who do we talk to? All of our organs, including our salivary glands, including our heart. And guess what? Is sympathetic going to be stimulatory to your heart? Yes. There's a train coming at me. Yeah? But is it going to make my stomach and intestines speed up? No, it's going to make it slow down. Are you with me? Does it use acetylcholine? What's it use? Norepinephrine. But it is stimulatory for the heart, but inhibitory for your intestines and your salivary glands. It makes this slow down while making that speed up. Isn't that interesting? It's one chemical, but it has 2 totally opposite effects depending on who the organ is. Skip this for right now. How about your parasympathetic, your rest and digest, right? What does it use?
Acetylcholine.
Acetylcholine. But does it speed up your heart? No, it inhibits your heart while speeding up your digestion. That's why it's rest and digest. Got it? They just wanted to come up with 2 quick words that rhyme. Like fight, flight, rest, digest. Got it? That's all. Why? So it can be remembered easily. Okay? So that's why your parasympathetic and sympathetic can be both stimulatory or inhibitory depending on who the target organ, who the effector is. The one we're trying to affect. The one we're trying to make do something. Does that make sense? Okay. Now we're going to get into the weeds. This is a little bit harder part. Okay? A little bit harder. Every first neuron is going to use what?
Acetylcholine.
Acetylcholine. So the preganglionic is always going to use ACH. Just like this one always uses ACH. It's only the post that is either NE or ACH, depending on whether it's sympathetic or parasympathetic. Does that make sense? So, on my test, if I ask you, who is the only neuron that uses norepinephrine, what are you going to say on my test? Who's the only one that uses norepinephrine? Post-ganglionic, what? Sympathetic. Not the pre, but only the post. Does his use? No. Pre and post are both acetylcholine. You're the pre, not the post. And the reason they've added this is because your sympathetic nervous system also tells your adrenal gland, the little hat-shaped thing on top of your kidney, to release epinephrine and norepinephrine, but this time in your blood, not in a second neuron. But it works the same way. Acetylcholine. Got it? So don't worry about this so much. This is really chapter 17, the first chapter in 211 next semester, the hormone chapter. We're dealing with nerves. Okay? Got it? One more thing. Are these all the same length? Are these all the same length? The answer is no, they are not. And I'll explain that to you in just a second. Oh, okay, I'll have to get to that. They aren't. Short first, no, sorry. Long, short. Short, then long, long, then short. Just put that in your notes. Your sympathetics are short, pre, long, post. Your parasympathetic are long, pre, short, post. Okay? And I'll show you in a minute, once we get through this, why that is. Now, do I have a lot of myelin here like I do here?
Yes. No.
What's this? Heavy. What's this?
Lightly.
Light. So who's going to go faster?
Heavy.
Because I got to get my hand out of the fire. That's self-preservation. I want this to be the fastest. You know, remember the jumping saltatory? This can jump a little slower because I'm just talking to my heart to speed it up. I'm just going to talk to my intestines to slow them down. It's not life and death. Does that make sense? And even, look, the second one is actually what?
9.
Yeah. It's even unmodulated. It's even slower. Because moving, telling your heart to move and telling your intestines to move is not life and death, like getting your hand out of the fire so you can use your hand again. Are you with me? Okay. Now, all of your organs are dual innervated. They have nerves from both of them. Why? Because they have opposite effects. And we know that. We've just said that. One speeds up your heart, one slows down your heart. Isn't that the opposite effect? Yeah. Same heart. Rest and digest. What's rest and digest going to do? Well, it's exactly what happens to you when you've eaten a big meal. Do you feel like running around or sitting on the couch? Vegging out. Yeah. Because it slows down your heart rate, slows lowers your blood pressure, lowers your breathing rate. But it speeds up digestion, it speeds up your saliva, it speeds up that kind of stuff. Okay? Who's the number one parasympathetic nerve that was on our quiz today? Vagus. Your vagus nerve comes down both sides of your neck. You give somebody a neck rub, that person is going to slow down their heart rate. You know, when you go to the spa at some place and somebody, is that to jack you up or to calm you down?
Calm you down.
And when you do this to your dog or your kitty cat, do they speed up or do they slow down? You're stimulating their vagus nerve. That's what you're doing when you're scratching them behind the ear. That's why they, right? I don't know if I said this to you guys before or not. I had a little kitty cat when I was a kid, a long time ago, Kimberly. She was a Persian kitty cat. And when you scratched her, she would, and then she started drooling like crazy. Because it speeds up her rest and digests, including your saliva. Are you with me? All right. And look, your pupils constrict so you can see up close. Do you want to see up close or see far away when you're studying?
Up close.
So do you want to be jacked up or calm?
Calm.
See another reason why we don't want to cram and wait till the last second to study? Even your eyes won't help you. Okay? All right. Fight or flight. Heart's going to speed up because I got to get the blood where?
Everywhere else.
Arms and legs. I've got to do fighting or running away. Flight. Are you with me? So where's all the blood? Here. So we're going to shunt it over to here, which slows this down. Got it? That's why you don't see anybody eating a big meal and then going out and playing football. Or eating a big meal and going out running. Does that make sense? You don't do that. When do marathon runners have their big meals? The night before. So it's all digested and out of the way, but the good stuff is stored in your glycosomes. Got it? So you can run your 6 or 7 hours for the marathon. Are you with me? You don't eat before you run because all the blood's going to go here and none's going to go to your arms and legs and you're going to fall over. All right. And look, your bronchioles will dilate. What does that mean? Close up or open up? Yeah, exactly. Okay. When you're in fight or flight, don't you need to breathe? So guess what is in asthma medication? Yeah. Things that are sympathetic. Chemicals that might speed up your heart. So if you already have high blood pressure, should you be using this rescue inhaler 10 times a day? That's why it's called a rescue inhaler. You use it when you can't breathe. But not all the time. Use a corticosteroid all the time. Pardon me. As my asthma kicks in. No. Woo! All right. Are you with me? So, when your bronchioles open up so you can breathe, your heart rate's going to go up. Your blood pressure is going to go up. 10-4. What's going to slow down? Digestion, including your salivary glands. When you don't make any saliva, what's that called? Dry mouth. Anybody ever heard of dry mouth? What's the problem with having a dry mouth and not enough saliva? You don't wash the bacteria down your throat and they stay on your tongue and on your teeth. And what does bacteria in your mouth lead to? Bad breath. And there's commercials out there. Hey, Biotine, it's better for you, blah, 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 blah. Why? Because so many of us are on sympathomimetic drugs. Write this down. Sympathomimetic. What does a mimic do?
Copies.
Or a mime? Have you heard of a mime? Yeah. Pretend he's in a box, right? Okay. So this is a drug that copies what? Fight or flight. So the medicines for opening up your bronchioles is called a sympathomimetic drug. There's a commercial on TV that says, when I have a cold, I take chlorocidin. It's the box with the heart on it. So you gotta listen to what she's talking about. She goes, I have high blood pressure, and normal cold medicines will make my blood pressure higher. Why? Because what's in a cold medicine? This. To do what? Open your nose and open your lungs so you can breathe. But guess what else it's going to do? Jack up your blood pressure. So she says, I take chlorocidin because it's heart friendly. Got it? It's not sympathomimetic. Are you with me? Okay. All right. So, look at some of the things that we do. Sympathetic. Blood flow to the arms and the legs. Okay? We increase blood pressure and heart rate to get that blood over there quick. Bronchioles open up. Blood flow to the organs slows down. Okay? Sweat glands. More. Pupils dilate. Anybody got a kitty cat at home? When you dangle something in front of her eyes, what do her eyes do? Because that is the killer instinct. That is the predator instinct. When you see something moving, you want to catch it. So she immediately switches into sympathetic mode. Why do you want your pupils to open when you're in fight or flight?
Get more light in your eyes.
Yeah, get more light in your eyes so you can either see where your enemy is or see where an escape route is. So is that for close work or far away? Far away. When you're jacked up, that's not the time to be reading. Are you with me? Because your eyes are this wide. You can't focus. That's for seeing far away so you can, hey, can I make it to that tree before that bear gets me? Does that make sense? Okay. It's not like, gee, I wonder if he'll like the story of Goldilocks. I'll read that to him. Maybe he won't eat me. No, that's not exactly what's going to happen. All right, your metabolism goes up. And oh, look, that's what's responsible for ejaculation. And mental alertness. Now, that's mental alertness like, I got to get out of here. Mental alertness. Okay, how about this? Parasympathetic. Heart rate down, contractions down, bronchioles constrict. I don't need to be running around. I'm sitting on the couch. But my digestion goes up. My skin is nice and warm instead of cold and clammy. My pupils constrict for close vision. And look, that's responsible for the erection. Okay? Now, all I'm saying is, ladies, if your significant other is having a hard time, don't yell and scream. Don't beat it against the bedpost. It's not going to work. Got it? All right. Because you don't want to get in sympathetic mode. You want them in parasympathetic mode. 10-4? Okay. Now, long and short. I usually get a bigger laugh than I do. Okay. But it's true. Don't beat it against the headboard. It's not going to work. This is why I want you to remember who's long pre and short post. Ready? It depends on where they come from. Where do all of your sympathetic nerves come out of? The middle of your back. Where do all your parasympathetic nerves come from? Out of your brain and your butt. Here we go. Watch. Look at your sympathetic. A very short pre going into the sympathetic chain ganglia. Remember, that goes down the side of your spinal cord. And then a longer post-ganglionic going to your organs. Short pre, long post. Why? Because the short pre goes into your ganglion on the side of your spinal cord. This close to your spinal cord. Let me show you. Where are all these? Right next to the spinal cord, aren't they? You actually have one on each side. Okay? They don't do it on one side. This is called the sympathetic chain ganglia. Because those are the ganglia where they meet, pre and post meet, and they're chained together. Got it? All the way down. See? Short pre, longer post. Everybody with me? Okay. Now, look at your para, the purple ones. They come out of the medulla. Long pre, short post. Long pre, short post. And notice, aren't they all going to the same organs? That's why they're parallel to each other. But nature keeps it straight by making it short followed by long, or long followed by short, by making sure these are norepinephrine and these are epinephrine, and these are acetylcholine. That's how your body keeps track to make sure it's doing it right. Are we running out of time?
Yes, sir.
All right. You want to stop right here then? And we'll finish this off next time? All right. Thank you, Albert. You're already packing, so yeah.